All right, so how about a tertiary alcohol dehydration? So in your course packet, you already have this setup, and you have the text below. This is a really good time to test yourself, guys. You know the conditions, you know the products. Draw a mechanism for this. You should know how to do that already. We just did it for a secondary alcohol. It's going to be really similar. And then try and fill in those blanks too. So you're paused. You're doing that right now. Now we're back. All right, so tertiary alcohol, same functional group. Functional groups do very similar things, so this is going to do the same thing. We have our sulfuric acid. We have our alcohol. It's a base. This is an acid, so we're going to get that same acid-base transfer. That changes our pore leaving group. This is a pore leaving group, the alcohol by itself, into essentially a hydronium ion analog that is going to be a really good leaving group. And we have the anion of the sulfuric acid. So at this point, is this going to undergo a bimolecular mechanism or a unimolecular mechanism? Well, we have a really good leaving group. That's a good start. It can do one of those two things. Do we have a strong nucleophile around? No, we don't. So this is a tertiary alcohol. Tertiary alcohols, tertiary leaving groups form really stable tertiary carbocations. So that's what's going to happen. The alcohol is going to grab its electrons for itself. That's going to provide this carbocation here. And the beta hydrogen right in that position can be deprotonated by water or the conjugate base of sulfuric acid to provide that product. Again, I think people get really bogged down in these little details. Is it sulfuric acid's counterion or conjugate base, or is it water that pulls off that proton? The real answer is it doesn't really matter that much. They're really similar in their basicity. It's really going to depend on the concentration as much as anything else. If this is neat sulfuric acid, so pure 100% sulfuric acid, there's going to be so many of these anions around that they might be more likely to bump into that hydrogen. If we're in a concentrated aqueous solution of sulfuric acid, there might be a lot of water molecules around that can pull that proton off. But really, it doesn't matter. It's one of those two things that is going to pull the proton off. Water is technically slightly stronger as a base, so we'll use that this time. And that would lead to that dehydration. Sure, this is no longer water, but there are other waters around. Really, what we care about the most is the organic product that's there. But the really important point is that this is a tertiary alcohol. It's a tertiary leaving group forming a really stable carbocation, so that can happen by an E1 type mechanism. Formation of that carbocation, then elimination. What's the other product? Anyone else put the other product up here? I put in this beta hydrogen, but again, remember, other beta hydrogens exist as well. This is the most stable product. This is tri-substituted, but if the water molecule instead were to grab that proton, I'm going to use a different color just to indicate that there are different things that are happening. So maybe 90% of the molecules do that, but also some percentage do this other elimination to provide a di-substituted alkene as the product. So we're going to get a mixture of products here. This is going to be the major product because it's tri-substituted. This is a minor product because it's di-substituted. So looking at the blanks below, we have a blank in the reaction. How does that relate to the one we saw above? The one we saw above was secondary leaving group. This is a tertiary leaving group. So we formed a tertiary leaving group in this reaction. So an E1 or E2 mechanism can occur. Remember, E2 mechanisms can occur on tertiary leaving groups just like E1 can. But then the next bullet point says we, and then blank, have a strong base / nucleophile. We do not have a strong base / nucleophile, so an E1 type mechanism occurs. For these reasons, tertiary alcohols, like this one, dehydrate via an E1 mechanism. So All important points. All right, moving on.